Good afternoon, everyone, and welcome to Loughborough University's Institute of Advanced Studies. I'm Professor Ksenia Chmutin, I'm Director of the IIS, and it's wonderful to have so many of you in the room today and people online. Welcome. As many of you know, there are many familiar faces in the room today. The International House, the home of the IIS, is the place where we meet for creative discussions, for most interesting, intellectual, inspiring debates. And this is the place where we meet to discuss the topics that are really important to humanity. So today is a great example of that. We're going to talk about urban mobility. This is the topic that has been coming up quite a lot in the last couple of years. So it's fantastic to see the continuity. And we would like to welcome our Open Program Fellow, Mrinal. So welcome to the IIS. Just a couple of housekeeping rules. We are recording the presentation, and the presentation will be available on our YouTube channel and as a podcast, but we will not be recording question and answer session. So, feel free to comment. For those of you online, please post your comments in the Q&A section, and we will bring them onto the screen during the Q&A segment. We should have at least 10 minutes for questions. I think that's it. And without any further ado, I would love to pass to Haikal, who is hosting our fellow.
Thank you, Ksenia. So it's a great pleasure for me to introduce you to Dr. Mrinal Bachute from Symbiosis Institute of Technology in India. Dr. Bachute has over 20 years of experiences developing AI applications for industrial innovations, with a particular focus on transport systems. In addition to her academic role, what is to me the most impressive is that Dr. Bachute is also the head of Industry Connect of the Institute, having worked collaboratively with over 100 industry partners in India, with very broad connections and relationship with the transport industry in India. So we're very much looking forward for Dr. Bachute to open the door for us in working together with new industry partner in India. And as some of you might know, it's not the first time that Dr. Bachute has visited Loughborough University. She was already here earlier this year in February through funded UK-India collaborative project. And she was hosted by the head of our school as well as our VC. And taking that opportunity, Dr. Bachute has set up an institutional collaboration between Loughborough University and Symbiosis Institute of Technology. And taking this visit, we're very much looking forward to deepen that collaboration. And Dr. Bachute is very interested in talking to colleagues and PhD students here to hear about your research and your ideas for collaboration and what you want, who you want to collaborate with in terms of industry partners in India. And we're very much looking forward to long-term collaboration with their institute and in India moving forward. So without further ado, we'll pass on to Dr. Bachute.
Thank you so much for the warm welcome. And I wish you all a productive 1 hour of discussion, wherein I'll be talking about, basically, I'll be talking about what work I'm doing with my research scholars. So the focus for today is AI-driven innovation and smart and sustainable urban mobility. As I said, that I'm heading Industry Connect, so I have a lot of industry connections wherein my main focus is making the research industry aligned. The research should not only be into the research publications or patents, but they should be, useful to the common society. So that is the whole intention of my department. And let me take you through this journey. This is Symbiosis International University. You can see the aerial view of it. It's lush green campus, 500 acres, around 500 acres of campus, wherein you have towards the left side an engineering college, towards the right is a medical college, and the research centers are there. So it's a complete ecosystem, and then we have a management studies, then computer studies, so many schools are there. So it's a wonderful campus. This is Loughborough. So you can see there's a lot of common things between both lush green campus. And this is my office. I am based on the third floor. I sit over here with my research scholars, and I work in various domains, applying AI into automotive sector, applying AI into ITS, intelligent transportation systems, and specifically now, I would say that this is based in Pune. So Pune is a cultural hub. You can see there's a lot of forts, and then palaces, and then the locations it's a must visit. So it's having a rich heritage. And talking about Industry Connect, so I have started, entirely spearheading the entire ecosystem, developing it from starting from one single MOU to almost 100 plus MOUs with the industries, 3,000 linkages, and having a very dynamic collaborative environment ecosystem at SIT. And these are the key differentiators and achievements which we have achieved till now. We have a strong collaboration with the academia as well as the industry, wherein curriculum inputs, innovation, center of excellence has been established. So Bajaj, which is a very leading company, which has established a 30 crores of lab, entire floor is supported and funded by the Bajaj. And then we have a lot of things like knowledge sharing, leadership, consulting, which we do for the industry, trainings, which we conduct for the industry. And to mention a few collaborations, we have a collaboration with L&T, wherein our focus is for innovation and skilling, because when we talk about a lot of research happens at the institute, how can we bridge this gap between academia and industry and make it more industry relevant. So that is the main intention. And so these are the few collaborations with Bajaj, Electro. And then when Loughborough team had visited back in 2024, we had a very nice conference which was scheduled for 148 participants across Pune, 48 members who had come, 148 members, all were the leadership, the CEO, CTO, CXOs, president, vice presidents of the specific verticals and the companies which were into the domain of electric vehicles, two-wheelers, four-wheelers, entire manufacturing sector. And we had Janet Godsil and the entire team from Loughborough had come, and we had good workshops, not only based in our campus, but we also had very good interactions with the industry. So what I did is, along with the participants, I had scheduled very nice visits. Of course, if you are also interested, I would like to invite you to India, to Symbiosis, and this ARAI, Tata Motors, Spark Minda, Bajaj. ARAI is a government organization in India. Each of the vehicle is tested and certified by ARAI, and then only it comes on road. So we had been there, then we had been to Tata Motors factory, where entire manufacturing plant is led by women, right from top to bottom. Everyone is like, the entire plant is women led. So then I had been here, as Haita did mention, that I had been here and had a very good interaction with the people who had come across for the Interact UK closing ceremony, and I had been delivering sessions in the school, as well as I had very good interactions with the Vice Chancellor, as well as the Dean, very fruitful discussions. And we have a lot of joint collaborations earlier. We already have an MOU in place, so which makes our work very easy for, say, 4+1 for all the departments, that is all the domains. And then there were certain international research sprints which were being conducted at Symbiosis. We had the conferences which were done and the IIS Open Fellowship. Then next month, one of my colleagues, she'll be visiting. She has been awarded, her project has been awarded by CDICE for the network sprint, which has been conducted in spatial data science domain. So this is what is like already many things have been built. So I would say that uh, coming to urban mobility and what work I am doing along with my research scholars, in urban mobility, what we face is basically rapid urbanization, climate imperatives, and equity mandates. So, the way it is moving ahead, we need to use or include AI because it is so very demanding. So, AI revolutionization is needed, AI adoption is no longer optional, basically, multi trillion dollar impact across the entire domain, smart cities, manufacturing, supply chain. So, this is what whenever I am interacting with the industry leaders, a lot of emphasis is on involving AI into these particular. So, what are the modern AI tools we are using? Is edge computing, digital twin, agentic AI. Then, of course, traditional AI ML is there. Apart from that, generative AI, and then when we have lot of learnings which should happen between the connections, we have graph neural networks. So that learns from the graph, structured data, and the relevant patterns. So generative AI, most of you might know that generative AI, there's a lot of data sources which is available. So large scale multi-model data is available, and then tokenization happens. Then there's a two phases: training phase, testing phase. And when you get the output, there's a feedback, there's a fine tuning which happens. So this is about generative AI. And then you have graph neural networks where aggregate, transform, activate, and you again residue, that is, you again give a feedback and then check it whether it is working properly. Now let me talk, my focus will be on agentic AI over here. So agentic AI continuously and precisely, there's reasoning, and this acts account automatically to achieve the objectives. We have to set certain objectives. I would say that in agentic AI, there's so much we can do. My students and we are doing that. We can plan one workshop for 2 days or 3 days for diverse audience who work in this particular domain. So, talking about digital twin, rather than actually intervening with the process which is happening in the manufacturing sector, taking out and creating a simulation version of this digital twin, interfacing the real time sensors and processing this, and then working on the simulated model and understanding how it is moving ahead. This is the best benefit of digital twin. And edge computing comes into picture when you do not want any delay. Time is a very crucial thing. So wherever the data storage devices are there, this local processing analytic hardware is based over there very close to the data source, so that we avoid any kind of delays and the processing becomes very, very fast. So while we talk about these widespread impact, me and my research scholars, we are working in several verticals like smart cities, then biopharma, manufacturing, and global supply chain. So of course, the main challenge is data collection, because when I'm working with the data, maybe in Indian context, my algorithm might work properly, but then if I want my system to also work in UK context, then also we require the data and vice versa. So the data is really very important. Now, what is the impact? The urban challenge. What is the challenge? So driver loses around 100 plus hours per year in congestion, according to INRX report 2022. And urban, say, traffic, 25% of traffic and 30% of CO2 emission is noted in WEF 2023 report. Then 70% of the global population will live in the cities. And are we ready for that kind of heavy infrastructure? So that is what is mentioned in UN report. So by 2050, one should be ready with this all facilities. So smart cities and what is the market? Basically, there's a lot of investment which is happening in AI-based smart city, building sustainable, livable urban future. So I must say that it's a big market which is transforming the living. And then when we talk about AI in smart cities, we are working into all these domains. that is digital twin graph neural network. And let me show you my research project, which I have been working, and what was the inspiration to work on. The inspiration was, what we did is we did some case studies where have been it implemented earlier. So it was earlier implemented in several cities. So these are the city case studies in Singapore, in Dubai, Barcelona. There's a lot of work which already has been happening in autonomous traffic by using digital twin, then faster and emergency responses for predictive infrastructure. Imagine that you get the predictive analytics on your mobile phone before you start your journey. There's a lot of course, you get a little bit by using the GPS and all, but then imagine it is becoming more and more smarter by using agentic AI, which is the future. And what will be the outcome? 30 to 40% traffic reduction, energy saving, then faster emergency response. Suppose there's a emergency vehicle or certain emergency transitions which are to be happening, then we can give those kind of facilities through our system. Improved air quality, that is the big impact. So me and my research scholars, we are working on autonomous driving system, very interesting work. So what we did is extensive literature review was done. Around 485 research papers where down the line 5 to 10 years we try to get those papers, and few top papers we tried to analyze. My research scholar and my team, we tried to analyze it. What is basically the impact of course, this is a research which is in progress, and it will be there for a couple of years. Why? Because there are certain levels of automation. When we talk about autonomous driving systems, you can see there's level 0, 1, 2, 3, 4, and 5. Now, level 0 was no automation. Level 1 is lateral or longitudinal controls. Now, what is lateral and longitudinal controls? Left turn, right turn. Whenever you're doing it manually, how about automating it? Right? And when we say longitudinal controls are acceleration, braking system when you're in your car, right? So both. Level 2 is both lateral and longitudinal controls, right? Now, most of the autonomy and these autonomy is aligned with the SAE standard, that is our Society of Automotive Engineering standards. So there are 3 to 4 standards, and the latest one is J3016. And based on that, most of the people or most of the autonomous driving system lie in level 1, 2, and very few in 3. So what is the aim? Aim of our work is how we can move ahead, march towards level 3, 4, and ultimately reach level 5. So that was the intention. And why this is important? Because of course, fuel efficiency is there. Then there are different passenger profiles, could be young, old, and disabled. So how we can make it very friendly for everyone. And some would be very heighted, and then some would be having very less height, then how the adjustments could be there. So how this can happen automatically. And then what is the feasibility? There's availability of different technologies which is present. There are a lot of sensors, technology that I was talking about, IoT sensors, integrating that, then using cameras, then using the computer vision, artificial intelligence, communication, and it's a multidisciplinary entire structure. Well, of course, there's high complexity, and there are different subsystems which are extremely connected, and there are challenges as well. What are the challenges? Safety aspects are there, identifying the pedestrian, identifying the object, and then there are so many things like crash and operational and non-collision safety measures. So this is definitely maturing, and there is a lot of scope for research in this particular area. Of course, this is relevant because people are like, all countries are investing huge amount in this, and there's a competition, I would say, who will do the first. So there's a lot of scope for this, and I'll talk about semantic segmentation. What we do is we classify each pixel which belongs to a particular label. And what are the labels? So you can see the top, the image is, you can see over here, there's an image which is showing the road, and you can see there are trees, then there are walking paths. So that is all semantically segmented. So you can see over here one example. So optimization by using the semantic segmentation algorithm, what we did is we tried and saw what other researchers have done till now before we started our work. Okay, we referred to all the literature, and we came out with some very interesting algorithms. And this was the research methodology. What we defined the scope of the research, we defined the objectives, then literature review, testing, validation, and the other things, of course, will fall. Now, one thing was optimization of semantic segment algorithm. So you can see this is the autonomous driving task, and what we did was semantic segmentation based algorithms. Earlier, it was used for agriculture, it was used for cancer detection. So we tried using this for semantic segmentation of the roads in case of autonomous cars, right? First, we use the unit algorithm, and you can see the images, 600 total Carla images were used. The original image data size was 300, and we masked the data size, the images, we trained the data, then we tested, then we did the validation. So you can see there was optimization based on certain 5 to 7 parameters. So when we did this, we found out that there are different optimization techniques. Which are those? These are the 5 optimization techniques which we found out. No batch normalization, then filter reduction, average ensemble, weighted ensemble. So we simulated maybe first initially by using the Python, then Carla simulator was used. We used Carla to capture the images, and then we created our data set. We also used few data sets which were readily available in order to first work on it. Then model was trained, then testing was done, and then result analysis was done. So we built the unit model in Keras, and then the model compiling. So this was the flow which we had used. Now what happened by using these techniques? We also filtered, we used certain techniques called as filter reduction technique, average ensemble modeling. Just now I did mention about this, and weighted average ensemble modeling techniques, right? So this gives you a glimpse of how the complexity and how the flow of the image data happens in this particular. And these are the results which we obtained from this particular optimization. So what we did is we considered these parameters: training loss, training accuracy, then what is the validation loss, then mean, dice matrix, so all these parameters, and then we compared the optimization techniques, all the 5 optimization techniques, and then gradually what happened was certain things were started revealing, and we built the model, and this is the outcome of the model which we have built, unit model. Okay, so you can see this is a test image, and you can see there's a ground truth image, and then there's a predicted image. So here, when you compare the predicted image with the ground truth image, you can see that, yeah, pretty good. You are able to find out which is the specific, segment for road, which is the segment for, the buildings and other locations in the image. So this was the outcome from the model. Then what we try to do is we try to use the ensemble modeling. Then while doing this, what was the data set? We used the Cambridge driven labeled video database. We also created a few of ours, and all these data sets, there were 11 classes which we used: sky, building, pole, road, pavement, tree, because we need to identify, and that's the whole aim of our work, right? So find out where the fence is, where the car is, where the pedestrian is, and the unlabeled things. Now, the 12th class contains unlabeled data, which is ignored while training in this particular research work. Now, while doing this, the parameter values for augmentation was considered, like horizontal flip was 0.5, shifting scale. Then we considered all these augmentation values, and we augmented the data. So you can see the parameter value of different versions of efficient net. By using the CamVid image, we pre-processed it, then the data augmentation was done, and the unit model was used, and you can see the model ENet B0, B1, B2, B3 different conditions we have used. So efficient net for B0 with width 1, depth 1, resolution 224. So likewise variations were done, and B0 to B7 testings we did in this particular methodology. And then we ultimately we were trying to see how much we can reduce the error and how much it is getting better and better. So as I said, there is training phase, testing phase, right? Of course, there's a validation phase. So these are some results: losses, F1 score, precision, recall, and accuracy. So you can see the accuracy is getting better and better as the data is also increasing, and as we go on changing and training the system. So ultimately, I would say that when we are using the average and weighted average ensemble, what's the weight which we are using? Say average ensemble is equal weight, whereas weighted average ensemble W1 is 0.3 and W2 is also 0.3, W3 is 0.4, like this. And weighted average optimized ensemble model is used. And what we have done is then we saw how the outcomes would come. We gave some test images. And are we able, and we tried in all possible combinations like proper daylight, night light, or very less light, all kind of weather conditions when it is foggy, whenever, of course, we didn't get much images of foggy and other things, but whatever data we could manage, we were able to do this. And the test image, you can see the result. This is the ground truth, and this is the image predicted. So this is the performance. You can see that the feature extraction with efficient net encoders are highly discriminative and increases the model segmentation performance. So what is, I would say that efficient net as a backbone to achieve the superior trade-off between what? Accuracy and efficiency. So let me show what we did by using the EUNet. Now we are doing it by using deep lab algorithm. So deep lab algorithm, now this work is published in Methodics Q2 journal, which is a Scopus journal, and then some work is also published in Q1 SCI journal. So I think in all four research papers are published on this particular work. So you can see this is another algorithm which we worked on, deep lab algorithm, and ensemble modeling was used. And then this is the methodology which was used. And you can see it's getting much better and better. So apart from that, we use different backbones like RASNet 50v2. And then we also, what we did was we squeeze and excite the model. Then we use the convolutional block attention model. So you can see how the specific combinations work with the deep lab net V3, deep lab V3 with different backbones like efficient net and squeeze net. And then, so these are the results. While we had trained this model, the accuracy, loss, and you can see the training and validation for different with CBM, also convolutional block attention model, then squeeze and excitation model, which is called as SE. So you can see over here how the result accuracies is. So during the training, we are getting 97%, and then validation, you're getting 91%. Then again, we tried to improve it. So you can see that different test models were done. Then what we did is this work was not enough. We thought that what are the different kinds of tasks which we need to take into consideration. The tasks are like perception. So these are total almost, I would say, 7 to 10 tasks. So 5 optimization techniques are there, and 10 autonomous driving tasks are there. So these are the prioritized important driving tasks which one has to consider. And based on the literature, so 353 papers were referred, and reviewed. The 100 papers were reviewed almost, and we came into considering 3 SAE standards, and we finalized that these are the prioritized 10 tasks. Now we had 10 tasks in hand. So which are those tasks? So these tasks, 10 tasks are perception, road marking decision, traffic sign detection, motion planning, then self-localization, pedestrian detection, automated parking, fall detection, vehicle related cyber security. So these are all 10 tasks which also we took into consideration, and we are working on this. And then what we did is there were so much of work which was already being done. Then what we thought was, let us understand which task, which algorithm is mapped. So we did that mapping, the task and the algorithm mapping. And then we also found that in certain cases like perception, there are multiple algorithms which are present. And say, for example, for diagnosis, there's GWO, that is Gray Wolf Optimizer algorithm, which is present. So we tried to map everything into one particular table wherein we get an idea what all is existing and what all we can contribute in terms of modifying the existing systems, right? Then we classified and investigated on these algorithms for different driving tasks which I just mentioned, right? And after performing this investigation, we also considered different tasks. So you can see vehicle cybersecurity, fault diagnosis, automated parking, all particular things were considered, and we did this investigation. Pedestrian detection, which is also very crucial because you might have heard about the news. The autonomous car just went into the pedestrian lane. So it is very serious. But we cannot have any point not 1% of error in this situation, because it may ultimately affect the human being, isn't it? So we conducted a lot of experimentation. So we used the data set with Carla simulator in this particular case. And what we did is we considered the parameters. So total 600 images were considered. See the original image size, you can see the validation. Then we went on, we found out certain frameworks which are readily available, because we also should know what is actually happened rather than starting from scratch. So what we did is we found out what are readily available frameworks, and we evaluated these available frameworks for feasibilities and other relevant analysis. Then what did we do is, of course, based on all these analytics, we published our experimentation. We published one paper in machine learning with applications, and I'm very happy to share that this particular paper is cited almost 580 times. So the relevance of the work. Okay, so this is another paper which is optimization of semantic segmentation algorithm by using autonomous driving by using UNet architecture. So this is also published in IES, it's a Q2 journal. And then we have hybridization, that is hybrid efficient net architecture. So what we did was we took the existing models and we fine-tuned and added multiple layers to it and modified it. And then there was a lot of uh, of course there's a lot to be done as we lie in level 3 to 4, and our intention is to focus on full-fledged achieving level 4 and level 5. And moving ahead, when we talk about these global leaders, they are also working on this particular domain. And what are the key challenges? Key challenges are data quality and data availability. That is a big thing. Then apart from that, talent shortage in terms of expertise in bridging this gap, understanding the computer vision, understanding the imaging side of it, understanding the hardware side of it, as well as the software side of it. And then there are several security aspects and regulatory compliances, and then ROI. So we found that these were the challenges of the AI agent. Now, how this will work? Now, let me also tell you that while we were working this, AI based, agentic AI based demonstration, of course, I'll be giving. A few of my students, my undergrad students and postgrad students are working on agentic AI for traffic lane optimization. So I'll be very happy to show you the demonstration. So let me just give you a little bit of background of it. So AI agent in action, where you do is traffic optimization. Dynamic scene perceptions are there. Then what we did is we used Sumo for creating the scenes and simulation of the scene creation. Then JS was used, and then dynamic scene perception, intelligent decision making, and then ultimately we optimize the outcome. So let me show you that demo. Let me skip this. But yeah, before going to that demo, let me quickly tell about the AI agentic system. A lot of has been talked about it. But if at all we want to put everything into one particular slide, of course, this one slide is a 3 days hands-on workshop to implement it actually. So I would say that user first is input output, then you have orchestration. First, in input output, you have so many integrations, multi-model data can be integrated. This input could range between text, documents, image, video, audio. So this is all what you can bring into multi-model data. And there is responsibility, like orchestration happens. There's a framework which is called SDKs. And what we do is what we do is basically create responsible foundational kit, development kit. And there are additional tools which we need to integrate. So I must say that if you are interested, we can definitely have one hands-on workshop on this, wherein I can live actually show how we are integrating this orchestration layers, how are we actually integrating the text, documents, image, video, audio into our framework. So what we use here is guardrails, and we are using so many other techniques. Guardrail is one example. And then there is reasoning which happens. The reasoning layer is there. There's a separate reasoning layer in agentic, because the speciality of it is it works on its own intelligence. So reasoning is very, very important. Reasoning. So reasoning layer separates the agents from monolithic automations by providing a way to reason and call to the tools. So I can show you, like, I might have, like, I'm very confident you might have tried it also. Integrating different tools into your AI agent or automating your daily task. Anyone working in agentic AI from the room, just to get an idea? I know Haita is working, but apart from him, okay. So many times it happens that you've been getting so many emails, right? And if you want to keep a track on technology, what's happening, say then Gartner's hype cycle, say for example, and how you want to integrate your emails and bring that into your Excel sheet, and it should not be all entire email, only the action items where you need to pay your attention and use your brain. So you can automate it, everything, and pull it on your Excel sheet, right? And use an AI agent. Of course, you will be programming, and you will be giving the task, and you will be intervening it little bit. And then imagine everything happens automatically. So your productivity will increase every day. 2 to 3 hours of yours will be saved. So let me move ahead talking about data and tool. MCP servers are there, where all the coherent context is being stores, and then agent interoperability is there. Sales agent, doc agent, like that. You can have many agents based on your requirement. So it is really very interesting, but I will not go into much of the details, because I want to show you actually the project which has been built by using this AI based traffic control system. So over to my research scholars. They have joined from India, from Pune. They're working with me, and they'll be showing you a demonstration, a short demonstration, which will make you feel how the things have been working for AI agent-based traffic optimization. Milind, can you hear me? Prisha?
Yes, ma'am, we can hear you.
Yeah, Bharat, over to you. You can start the demonstration, Milind.
Good
Prisha.
afternoon, everyone. Our project's name is AI Agent Traffic Optimization. My teammates and I have been working on this as a part of our engineering course, and we are excited to share this with you today. So, we all know traffic congestion is one of the biggest challenges in modern cities. It wastes time, fuel, and also increases pollution. Our project uses artificial intelligence to make traffic signals smarter and also more adaptive in real time. So, the core of our system is an AI agent. In simple terms, an AI agent is a program that can observe its environment, make decisions, and take actions to achieve a goal, just like a human world. In our case, the AI agent continuously monitors traffic conditions and decides how to adjust the signal timings in real time to reduce waiting time and improve flow efficiency. Over to you, Milan.
So what we have built is a three-tier system. So the base of this would be Sumo, which is a simulation of urban mobility. Why we're using Sumo is because it simulates urban traffic, and using a API called Tracy, that is traffic control interface from Sumo, we are using it to connect it to the brain, that is our Python backend. So the AI agent, that is the brain, will make decisions based on the tools or parameters that we have given. And the third tier would be the front end, that is the React dashboard that we've built. So the React dashboard only shows you the output instead of all the calculations and all the other things. So what you can see right now is that the traffic is building up on the north-south lane, and it is calculating, and then it is letting that lane turn green. And as soon as the traffic congestion decreases and moves to a low traffic mode, the other lane is given priority. I would like to pass on to the Bharat to continue with the parameters.
Okay, so the main parameters we have counted here is actually experiential moving average. Since cars been passing every 5 seconds or so, we can't actually take the count of cars in per lane to actually calculate the density of the lanes. So we are using an average to smooth out everything, and we are comparing these averages using the AI model. So for this, the other one we have used is vehicle arrival rate. The arrival rate is to measure how quickly vehicles are entering a lane over time. So it shows the trend in traffic increase and decrease. Then also we are looking at lane wait time to see how long a lane is set to waiting since its last green signal. So there'll be a set threshold for it to change so that no lane is not given the red light for a long time. And other than that, the advantages of our project include adjusting the signal timing in real time based on traffic density, as I mentioned. And also, we can give priority to emergency vehicles like ambulances and other vehicles so that there will be no problem in impeding traffic. Also, traffic congestion and waiting time can be reduced using this. Yeah. Now I'll pass back to Melin to explain the code.
So this is the simulation that we've built. So in real time, we would be depending on camera feeds to provide us with the vehicle counts and onboarding, and we'd be using a Jetson Nano or a similar board to do the AI computation. We'll be using YOLO for object counting and image detection, and then after that, the YOLO will give the car count to the board, and the AI agent will input these numbers, calculate EMA, the vehicle arrival rate, and the wait times. And based on that, give an output, which will be the signal set to red or green or yellow. So this will be the real world impact of our project.
Okay, thank you so much, Milind, Bharat, and Prisha.
Welcome.
So let me come to my presentation. So this is work in progress, and we are using NVIDIA Jetson Nano board, wherein we are integrating and just creating a POC, proof of concept, so that we validate, verify, implement, verify, test, train, validate, and see whether it's working properly, so that we can approach and get more realistic data, maybe from India. And if we all, anyone interested, if we can join hands and then we can also test it for UK conditions and UK data. So this was the demonstration. So I think we have to go to the next slide. Yeah. So maybe I'll skip all this because already Milind, Prisha, and Bharat had spoke about. Now, what are the policy alignments or imperatives which are required? Of course, ethic is very important. AI agents are optimizers, so we must ensure that they optimize for human values and not just efficiency. We cannot just run behind efficiency. It should be more efficient, but it should be more ethical as well. And there are challenges like solving the reward specific problems. What is the challenge here is if designers fail to specify the contract correctly, then agent exploits, like the reward specific problems are there. Then net zero alignments, equitable access is also very crucial over here. And then what is the deployment roadmap is there in our mind, like by rigorous policy validations and safety assessment in controlled environment, by using maybe digital twin sandboxes, then agent training, calibration and optimization using the synthetic scenarios, and real world data is still work in progress. We need that. And anyone interested, of course, I would like to invite you to join hands and we can collaborate on this. And the edge development, edge deployment basically is validated intelligence deployed via edge computing for say real-time control executions. So that is also very, very important thing. And there are key success factors which we have thought of. And then what are the privacy protection? Federated learning keeps sensitive data localized. If we use federated learning, then what happens is we are able to, keep the sensitive data localized, and you are not, passing on that unwanted data to someone else, which might misuse the data. So mandatory interdisciplinary collaboration is very, very important to overcome this fragmentation of legacy systems, enabling truly embedded or adaptive cities. So what is the way forward? From managing the traffic to engineering the adaptive cities, I would say that there are three pillars. One, adaptive AI trades, and DTFLEC architecture and policy alignment. So these are the three important things which we need to think on. And of course, sustainability goals, SDG goals are there, carbon footprints, minimal emission, green logistics. So multi-agent coordination is used for, say, can be used for green logistics, and it will help reduce environmental impact. And there are so many outcomes which we have thought of. Also, I had some discussions with many of the people over here. I had discussions with Hightow. So we can also co-publish the research work and write joint publications, then submit to the funding organizations once we secure funding. Of course, we have planned, we can also plan a workshop, maybe in association with IIS. In future, we can do a hands-on, which I said, one slide of Agentic AI is as good as a 3 days hands-on workshop. So these are there are certain long-term goals in mind, wherein what we feel is we can also have one innovation hub across Symbiosis and Loughborough, IS being a leading front face for execution of this, and we can together create a bigger impact. So I say that the association has started already. We have done many things, but the association has started, and we can take it to the next level in coming days with the help of the contributions and collaborations from both sides. And also to mention that next month, the Interact extended funding executions will happen at Symbiosis, and we are organizing idea pop-ups for the industry, wherein the work which industry is doing will be displayed for the Loughborough UK team, and let's see how it shapes up. And thank you so much for patience listening, and I hope you all have a productive hour, 1 hour, and I keep it open for Q&A. I would be happy to take questions, and I'm really eager to collaborate. I have big for a base of students, research scholars, and professors working in symbiosis in this particular allied domain. So we can definitely join hands and keep, the things rolling from both sides. So we can put it ahead. And now I'm open for questions. Thank you so much.